2020 version. We'll share the setup file so you can install 2020. Um, okay. First of all, I'll save the model of the name of the cloud view one. The dimensions are in mm, so I'll use that mm directly. 1000 by 1000 thickness of the slab is yes, what the heck? Thickness of the cover. Okay, 1000 by 1000 by 40 slab they have used.
Hmm. 40 slab,
1000
and they have used a
by
point 0.5 ton, 4.5 kg TNT, है ना? And its
yeah.
turned out distance is 0.4 meter.
Mm-hmm. That's just what's needed. Whatever operation I am carrying out, like right click or left click of the mouse, that will be visible over here, left hand side bottom corner. See, if I am clicking the left, it is visible. If
Hmm.
I am clicking the right, it is visible. So all my keystrokes will be visible over here. Now mark it 1000.
So, one question is that can we do it in SolidWorks and can bring it here also, no? Is it?
You can do no problem. No problem. So this is all that's 40 mm. My slab is ready.
There
Then
is a reinforcement also.
75 by 75 and 20 cover will be used. So save this sketch with the name of sketch one. I'll go out and the enforcement RF. I'll use as wire and I'll bring the sketch over here. Now I need 20 offset from either side. So I'll just randomly mark this. I need 20 offset and 20 offset, 20 offset. Okay. So this is my boundary line now, and my first reinforcement that also this is my first one plus control like this at a spacing of 75 I don't need this. Go on and preview. Okay. It has matched. It didn't match. It's coming somewhere here. So what you can do is let it be like this. Then a copy of this. Hate this one. Rotate 90 degree. I'll merge this one over here. So I need the midpoint. I'm creating this line just to get the midpoint. I'll take the midpoint. Yeah. So this is the midpoint. This is the midpoint of this assembly. And then this one from here to so I've got my reinforcement. Uh, Now I've got my reinforcement and just delete all this. To move my reinforcement. Simply go to assembly, then the button together. These are all geometric operations, so there is nothing to explain over here. If you need any specific explanations, then do let me know. I've got the midpoint. Now they have placed it most probably at a 20 spacing.
From
From
bottom.
bottom. So first of all, I need a midpoint. So the midpoint of the bottom. From there, I'll take on it x0, y0, z 20 Got the point. I'm gonna move this one over. If I just check the space perfectly, now I'm gonna rotate this one about y-axis, sorry, x-axis, and I rotate clockwise to -3. Just delete the data points that I have created, so don't confuse me. Now, to mark the standoff point, first I will mark a center point. What is the standoff distance?
0.4 meter.
Scaled distance and then, I guess
Top it.
0.684.
They have calculated this from the scale of distance, na, है ना?
Scale distance.
But here
Point
top it is given, na, in experimental terms, like it will say in experimental terms, it's given that uh, the explosive is located at a 0.4 mm standoff above the slab.
Okay, 0.4 mm.
Yeah, scale of distance we will take it during calculations, na, manual calculations.
Mm-hmm. Okay, I'll take 0.4. Right.
Yeah.
Take 0.4. So x will be 0, y will be 400, z will be 0. We'll just mark a reference point over here. Now, let us first finish the blast, loading, etc. Then I'll proceed with other. I'll go for air blast, equivalent mass of TNT. What they have given.
zero point 0.2 or 0.55 kgs.
See, this is 0.55 kg. Now you have to check what explosive they have used.
They have used TNT only. They have not that TNT, so there is no need for equivalent
Okay, no
TNT
problem. If
equivalent.
they have used TNT, no problem, 0.55. Let's say if they have used any other blast, then you need to scale it up
Make it equivalent to TNT.
equivalent to TNT. You can do it. So for the time being, it's okay. Now go over here, then sim. Okay, before that, I'll just create a
Acha,
step.
what? Just one question. What you have open? Like you are using Conweb.
Sorry,
You are using which setup of this ABAQUS Conweb
I didn't get you. Oh,
for
Conweb.
explosive
Yes,
setup?
yes, Conweb.
Okay.
Conweb. There is only one option in ABAQUS.
Hmm.
Most probably they are using just Conweb only. So just go to incident wave. Now it is asking for the source point. The reference point is my source, Conweb air blast, and this is my surface region on which the effective blast will be there. We have
Hmm.
selected the interaction property, time of detonation. So let's say I want the blast at 0.005 second. So scale
Okay.
back. This is the position where you need to scale up if you are using any other explosive apart from TNT. So
Hmm.
here it will be 1, or if you are using any other explosive and it is 1.5 times TNT, then you just have to use 1.5.
Okay. Yes.
Yes. Click OK.
Hmm.
So blast condition has been defined. Just we have to define the boundary condition. So most probably they have used roller boundary condition. Uh, I'll
Fixed,
just
not fixed, not fixed.
sorry.
Boundary condition means the slab is fixed, na?
Maybe it has been fixed, but I guess they have used simply supported. No, fixed. It is
Fixed.
fixed. Let me just check once. Okay, whatever. I'll just fix it. For the time being, I'll fix it.
Hmm. So just for my just knowledge, have you done anything initially for blast loadings?
Means
any like previously you have solved any thesis related to blast loading?
Yes.
Okay,
Why?
just asking, because generally people may not be doing all, because you were telling you are.
No, this is my full-time work, so I have done many works related to blast. So you'll get some model in my YouTube channel also. Those are
No,
available.
I've checked blast loading. You have not done blast loading any.
Usually, I do not share. Might I have not shared it, but yes, I have done many such work. So let's say this is the all. Just I've assigned the boundary condition. Blast has been assigned. Now
Hmm.
I'll just have to mesh it. I'll go and for the reinforcement, I'll use the default mesh, whatever mesh size has been given. You can change it
Hmm.
if you need, but here I'll use it as a truss, and I'll go for explicit truss.
Hmm.
Here they have used suggested 7.5, so I've used just 7.5 on. For slab, they've used 50, but I'll go little finer mesh for better visualization. Okay. Now here I need the center point, one node at the center. Yeah, I've got that node. This node I'll select it because that's where I need the result.
Okay.
Okay. The displacement pattern. So this is the node on which I need the displacement. So I've created that node with the name midpoint. I'll go to step. I need history output on that. So go to set midpoint. Then there I need the displacement, vertical displacement. And that's all. I field output. These are all okay. Usually this is not required. So it's okay. Failure. I'll be using concrete damage plasticity. So I'm requesting these two damages. Now I guess I'm done with all this. No
What is solver
mesh.
we are using here?
Explicit. Blast is always used in explicit.
Explicit means even in that also PPV we are using PPV.
Sorry?
Particle velocity wala we are taking na.
No, no, not now. Solver, this is dynamic explicit. So, dynamic explicit is, I guess you have read about the Newton-Raphson method and other methods for dynamic equation
Mm-hmm.
solution, right?
Acha, what I want to now I know is that material modeling you have done already. Material modeling you have not done,
Not
right?
yet. Not yet. Not yet.
You have to do it, no?
I prefer to assign material at at the end.
Okay.
So my now all these things are done. Hmm. One more thing is remaining is interaction. So in interaction, I have to give the interaction for the reinforcements. I'll use embedded. I'll hide the slab. I will simply record. So everything is done. Just I have to assign the properties, material properties. What happened? Okay, sorry. Okay. So first of all, I'll go with concrete. And they have suggested in the paper, if you see, they have used CDP for concrete. Yes.
Uh,
Is the grade of concrete they have used. Material for concrete. Open behavior characteristic. So in Abacus, they have done most probably in ANSYS, I guess. So in Abacus, the best material for representation is CDP. What they have for concrete, 39.5 density. Whatever the RCC
Johnson
composition.
Cook they have used for
Effectively for failure. Okay, they have used Johnson Cook for the
Steel.
concrete as well. It's okay, no problem. We'll use Johnson Cook
No, no,
also.
kindly use CDP. CDP is only the solution actually.
CDP is okay, but when there is a high rate of strain, because there is a blast loading, okay? So in blast loading, it's better to use uh, Johnson Cook model because it is able to capture the high rate of strain. This is the problem, high strain rate. So for
Then
concrete, it's okay. I'll
values,
use
how we are putting the values A, B, C, and then E, L, all these values.
all these values are here. You just use no instead of CDP for concrete as well. You can use as Johnson Cook model. Sorry, not this one.
What
Because
is my understanding till now is like we use for CDP for concrete and for steel we use Johnson Cook model. Can we have the two things separate also? Anna?
separate means
Separate means different material, different material model.
yes, definitely, definitely. See what they have done. They have used the elastic property, and in plastic property, they have simply used Johnson Cook for this concrete as well. So I'll go with it because CDP is easy. I guess if you have also tried, you might have also tried, right?
Hmm.
Or if you have not tried, no problem. I'll create both. No problem. I'll create both.
Okay, values are given for A. Values are given
Density
for
is
N.
given 255 gram per minute. It is 2550. It is
Yeah.
kg per meter cube. So we are working in mm. So e to the power minus 12. In abacus, whenever you are working in mm, it will be in ton per mm cube. Density will be in
Hmm.
ton per mm cube. So to know more, always just type ABAQUS UNIT. This is the unit you need to use. You'll get it in Google. Simply type abacus unit. If you are working in SI meter, then you have to follow this unit system. If you are working in SI mm, follow this. Density will always
Okay.
be in ton per mm cube. We are using SI mm. And mass will be in ton. Okay. Mass
Okay.
will be in ton.
Right.
So I guess I made one more mistake. Here, this is in kg, so I'll have to convert it in ton. So
Done.
I'll do it later. But before that, this is okay. Elastic modulus of elasticity. Elasticity. Modulus of elasticity, shear modulus 39.5. They have given mu. No. Okay, it's around 40 MPa. So for 40, the modulus of elasticity will be 45,000 square root FCK. Can I just find out? 40,
Concrete of 40 megapascals, na?
5,000 square root FCK into 5,000. It's 31,622.7. 31,622.7. Poisson's ratio, I'll take zero point 0.2. Then in plasticity, I'm gonna enter these values A and A B. A B is 1.6, 0.7. Oops, 6, 0.7. Now, what is the unit they are considering? That's the problem. What is the unit they have taken for this? Because this usually in MPA. What is an MPA? So, okay, most probably they have considered MPA only. N is 0.61, 0.61, and 0.7 D1, D2. M, what is M? M is 1, 2, 3, 4, 3, 0.8, 0.8. Any temperature data. A melting temperature, I'll take around 1600 or 1400. This is transition temperature, rate dependent, Johnson Cook, C value, given D1, D2, strain rate, epsilon dot 0, 0001. Let's see. So now,
4.6.
six.
No, no,
See, you
no.
can take 0.012, epsilon dot 0 is 1. This I will take epsilon dot 0.01. It's okay. So all the values are assigned,
Hmm.
plasticity, etc. Now this is Johnson book, and if you want to
What
get
C value strain rate? What you have taken?
here
0.0.
I have taken 0.001 and epsilon dot 0.01.
Okay.
Does they have given anything? I don't think so.
They have not given, but if they can tell material, then we can find it from the net. What material they have given?
Now I'll take this one only. 0.00008. 0.0008. Now this is for Johnson Cook. I'm gonna copy and I'll name it CDP as well. For CDP, I have to delete this one and CDP. I have these properties for different grade of materials. So in 40, I can I'm gonna use it. We are ready with this, and then I'll create one for steel. For steel, no doubt you have to go for Johnson Cook because that's the only option you have. It will be easy for capturing the behavior.
Yes, Johnson Cook is
Johnson Cook
better
is better.
for steel.
Temperature level, heat to the power, minus 12, elasticity, mid over 5, 0.3, and plasticity, Johnson Cook, A, B, A, B, 3.73. There's some problem with this value. It's not possible. It's not possible. This much strength of steel, not possible. Okay, okay, they have given here. Okay, clear.
They have done it Autodyne, huh?
Sorry?
They have done it solution in Autodyne, I think.
Yeah, not that. Tea room 300. A 792. B 510. The 60 0.014. M M 1.03 and A 0.26. Now you can go for ductile damage as well, but that values are not given. Johnson Cook damage. Here you need to enter D1, D2, D3, all this.
Mm-hmm.
But the
Actually, we
trouble.
have to know the material and then we have to go for the graph, and from the graph we have to extract the value of this 5D.
Hmm. You can get it, but right now I am not gonna use it.
Okay.
For me, plasticity is sufficient. I'll just assign the value. Let's go for CDP only. Price. And from here, steel, I need to know the area, cross section area. So let's say I'm gonna use 10 mm dia, so it will be 78.54 area.
Mm.
Yeah. If I just render the beam profile, this will not be a problem. So I guess yeah, I'm done with everything. I'll just go to job. Probably seconds I'm simulating. At six processors, I will six.
Acha, by default it uses 6 processor.
No, no, no. Check your task manager. There, go to this performance, and here see I have 10 cores. So I have six
Mm.
cores, primary cores, and four auxiliary cores. So I have given the command of all six cores. So for your case also, it will be some value will be written here.
Okay.
Yeah, please. So the model is completed. The problem is it didn't take any load. I just have to check why. 0.55 e to the power minus 3. That much done. Class will be at 0.005 second.
Time you have given too much, I think so. It should be in millisecond.
Yes, I've given 5 milliseconds and I'm simulating it for 0.01 second. 0.55 kg e to the power minus 3. It is asking mass to convert in kg. So it will be 1000.
Mm.
And this will be multiplied by 1000 to convert in kg. Conversion of length to meter. It will be 0.0001. I'm working in mm, right?
Mm.
So to convert mm in meter, I have to divide this. Conversion time for the one pressure to Pascal. Pressure here I'll get Newton per mm square. So it will be 1 e to the
Then
power
5.
minus 6, no, c to the power Newton per mm square. And to convert
Uh-huh.
in meter, 10 to the power minus 6, 10 to the power 6. Yeah, 1 to the power 6. That will be, now it's energy values. Okay,
Okay.
now it's so what happens in abacus if you are working in meter, okay, if you are working in meter and mm, then no problem. You just keep all these things will be one. But if you are working in or any other unit, you'll have to tell the software how to convert those unit in meter,
Okay.
meter and kg.
Mm-hmm.
So I hope this is clear to you.
Yeah, yeah, this is clear.
Now let us check the results. This is the behavior. If I just magnify this code annotation. If I just magnify the response, this is after magnification of 10 times. You have blast it 1 second and then it's vibrating. Now to check it, these are the energy plots and I have requested the displacements as well. Some are here, yeah, this is the displacement. This is the behavior. It is coming down, then it is vibrating over here. Okay. One thing I have forgotten is to give the gravity load. Minus 9810.
Acha, one thing I want to ask you.
Yes.
Uh, I can, if I have a PT curve, pressure type curve, huh?
What?
I have a PT curve, pressure time curve of any blast. If I know there is a blast and what is the PT curve of the blast, है ना?
Okay, pressure with respect to time. Okay, good. Then,
Pressure type, huh? And they will then work on the static type of loading, है ना?
yes, usually the people do not go for all these simulations.
Hmm.
So they find out the static pressure due to the dynamic effect of the blast and proceed
They
with the
multiply it
design.
with the dynamic load factor, है ना? And then,
Yes, yes, yes. That's what they usually the people does.
but why these values are not correct, kya? Or what we generally do some error while doing all these things?
Why these values are not correct means
Means why people generally go for the static one and then they calculate
see
the pressure
the thing
in
is
terms of
that
static.
the thing is that you can't say this value is correct. You know why?
Hmm.
There are many other factors. First of all, you don't know whether you are taking correct property or not.
Right.
First uncertainty, your properties are correct or not. This damage
Hmm.
density CDP parameter, whether they are correct or not. Who knows?
Hmm.
Until unless you
Hmm.
have verified it. So how to
Hmm.
verify? You have to use this property and for a model for which you have done a lab experiment. Then
Hmm.
if you have been able to match the property, then you can say, okay, these properties are correct. First
Hmm.
uncertainty is property. Second uncertainty is the meshing. So meshing there you have to perform the mesh convergence study. You can't say that mesh size that I have used 25 it is correct or 10 is correct. What you have to do, you have to do a mesh convergence study. So the mesh size on which the result does not change. Okay.
Hmm.
So I hope you know the mesh convergence study.
Not much. What we do in CFD, that study only you talking about.
Same. Means you take different mesh sizes and find out the result, and then you plot it. So if you change the mesh size, the result will be changing, but there will be a mesh size at which after which the result will remain constant. So that is your
Constant.
ideal mesh size.
Yes. Mhm.
Okay, so it is similar to a CFD or any other FM2. So then you have two uncertainty. One is property, then the meshing. Once you have done with all this, then you can proceed with the other things. But why to take so much of tension, or you need to know all these things to calculate the exact pressure. So it's better, instead of going for all this, just find out the static pressure and apply it. Though that is little bit overestimated, but it's still, your model will not fail, your model will be safe. But this type of analysis is done when you are interested in a particular type of research. You are testing a particular material other than any other material that is readily available. So in that cases, you need these things. So why are you looking for this blast loading? Is it for your academic purposes or any industrial purpose?
Actually, I have moved to one different project, है ना? The project actually all these days, we are looking after all these things, small small things. So I have been very new on this one. Very new means only 6 months.
So you are in industry.
Yeah.